So here is the basic formulation of a Java program. Now, in this case, it's on a website, but on the web hosting server, it's still in a file in the file system. And we see that in Java, all of our code must be wrapped up in classes, right? So here's another recipe. So let's call this recipe 3. In Java, all of our code, it's in a file to start with. And in other languages, it might be different, but we're only talking about Java today. Well, actually, in all languages, all of the code is in files. Where else would it be? Logically, like, think about it. That's the only place it could be. And you could have one program spread over several different files. Yeah, that can happen. We won't do that right away, but later we'll see we have 5 or 10 or 20 files for one program. For now, we'll just stick with one file. But all of your Java code must be contained in classes. That's your first big rule of today's lesson. That's just the way it is. Deal with it. One class will be public. You can have only one public class in a file. If you try to have two, you'll get a compiler error. We'll do the experiment and we'll see that that's true. One class must be public. Exactly one class. Not less, not more. Exactly one. There must be one and only one public class. Public is a visibility modifier. We'll talk about visibility modifiers next week. For right now, just put it and don't worry too much about what it means. And that public, so you now have, what do you have? You have a text file. And its extension is .java, .java, just like a Word document is .docx, or an Excel sheet is .xlsx. XLSX, I think, yeah. So you have, simplest case, one text file with an extension of .java. And it contains one public class. You can have other classes which are not public, but at minimum you have to have one public class. Your text file contains at least one public class. It can have other classes which are not public. And your one public class must have a method, and it must be called public static void main. Your public class must have at least, it can have more than one method, but it must have at least one method. A method called public static void main. Now we're ready to go and write a basic program, so let's do that. Yes, exactly. It's similar to the main function in C. Exactly it is. Yes, that's right. Yeah. And why it needs to have that has to do with something called the Java virtual machine, and we will talk about the mechanics of the Java virtual machine later on. But yes, in fact, most languages have that requirement, right? If they're object or if they're class oriented, they must have a main method because that's what the compiler or the interpreter looks at to start loading the program. Yes, exactly. Very good. So let's go and write some code now. So now we see here now we understand what we're seeing, right? Maybe you saw it before, but now you understand it has a very special meaning. There's our public. See, and look at the color coding. That's a keyword. And then you have class. And then you have a name. The name can be whatever you want. Work along with me now. And you must have public static void main. And there you can have some arguments. You don't have to have that. You could not have that. But if you have that, then if you pass parameters in when you call the program, they'll be processed. I don't want to go there right now. I want to talk about that next week. You don't need to have the ability to process command line programs. And let's try running this to make sure it still runs. So we'll say execute. Main method. Oh, I see. Yeah, sorry. I guess in their implementation of the JVM, it does need to have that. In other JVM. So anyway, just leave it there. It's not going to hurt you. So say execute. And we're getting hello world. Now you can change that. You can call it hello class. Or call it your friend's name or something. So now you've written the simplest Java program. It's not very interesting, but it's a Java program. It's doing the job. So now let's make something more interesting. Let's make a calculator, right? So I'll call it public class calculator. And here, you could put a bunch of stuff in your main method, but that would be a bad design. And I'll talk more about this next week when I talk about program design. But one of the things we want in an object-oriented language is modularity. We want the behaviors that the program is delivering to be put in their own methods. And when I talk about unified process, you will understand that. You may not really understand it now. In fact, you probably don't if it's the first time you've ever seen programming. But I'm just going to ask you to believe me for right now. In fact, for your tests, if you write all of your code in the main method and you don't use other classes, I'll give you a low mark. You want to have modularity. You want to break the things that that your program is doing into many little methods and classes. So let's make that a recipe. Let's say recipe 3. This is recipe 4 now, I guess. Recipe 4. It's a good design pattern. You should observe the good design practice in Java. Whoops, I have some comments coming in. Oh, I didn't process the unified process. I thought I did. Oh, yeah, that's right. I didn't hit the process because it was still uploading. Thank you for reminding me of that. Thank you. That's good. Let's go and do that now. Great. It's good you're interested in that. That's excellent. Very good. Maybe I closed the browser. Yeah, I guess I close. Oh, well, not a problem. I'll go and upload it again. So we'll say classroom. It's in your Dropbox as well. Let's log into here. Yes, I forgot. All right, not a problem. So let's do that. So let's say unified process methodology of software design. Unified process methodology of software. All right. All right, I'll be careful not to close this window till it's uploaded. Oh, it's already 3 of them. Maybe I'll just wait a minute to get it done. The video is going to take a while, though. Well, I'm going to come back to this. So, recipe 4, you should observe the software design best practices. Which teach us to break the behaviors that our program is delivering, to partition. The term they use actually is partition. All right, good. Now I got this. Great. Nice. Thank you for the reminder. You should observe the software design best practices, which teach us to partition, like in the house or the apartment you live in. You have a bedroom and a living room and a kitchen and a, maybe another bedroom or something, and they have walls between them. So that's partitioning. Partition is just like rooms. It's like spaces. You should observe the software design practices which teach us to partition the behaviors that our code is delivering. Into many small classes and methods. Why we want to have many small classes and methods instead of a few big ones has to do with the concept of high cohesion, low coupling, but I'm not going to talk about that till week 4 or week 5. I'm just going to leave a reminder to myself here. You should observe, the partition, the behaviors that our code is delivering into many small methods and classes, not a few big bloated ones. So we have about another half an hour, so let's jump in there and do a few good examples. So I want to make a calculator. So the only thing I ever want my main method to do is call other methods. I don't want to do any work in my main method except use it as a little checklist of calling other methods. So the meaning of this is the only things you should put in your main method are calls to other methods. That's all. You shouldn't do any work in the main method. You should only call other methods. So I want to make a calculator. Well, I want my calculator to be able to add numbers, right? So I'm going to say here public. That's the visibility modifier. What's a visibility modifier? I'm going to ask you to think about that later. We have other things we need to talk about first. For right now, just make it public, and we'll figure out why later on. So public. And now I have to have either static, or if I don't put static, it defaults to being instance. And I don't want to talk about static and instance right now, because we can defer. We can put that off till later. For right now, just don't think about it. But here I had public static void main, and here I'm just going to put public. Now here I had void. So void is the return type, and you must always have a return type, and void means the return type, it's nothing. It's not there. But I want to add numbers. Well, what if I say my return type is int, meaning integer? Let's try that. Maybe it'll work. I can have different return types, and they're all in your textbook, and we'll go and study it next week, but the most important ones are int, float, and double. Those are numbers. We can also have string, which is letters. We can have char, which is character, which is also letters. And we can have bool, which is Boolean true, false. All of that information is coming, but I just want to make a simple calculator for right now. So I want public int add, and the other thing my method has to have is some parameters. Well, okay, I'm adding numbers, so I need numbers to add. Why is that confusing? And my parameters must also have data types. Everything I'm telling you is in your textbook. You can go and read the textbook, and we'll read it together next week. But this is the first time you're seeing it, so I'm keeping it as simple as I can. So I'll say int number 1 and int number 2. And notice my color coding. You see how int, that's being recognized as a keyword by the Java runtime. So that is my method declaration. Next, in my curly brackets, I need to provide an implementation. I need to tell it what it's going to do, and I want it to add 2 numbers. So I want to say return, because methods return stuff, unless they're void. Notice our method up here is not returning anything. Why? Because it's a void. If it's void, it doesn't return. If it does return something, then it has to return the data type of what you are saying you want to return. Remember Susan, who did not worry about details. She just grabbed the gun and started shooting. Just grab your keyboard and start coding. Do not overthink it. If you overthink it, you're going to scare yourself. You're going to get frightened. If you just do what I tell you, the understanding will come in a little while. Probably by like next week or something. So we're going to return number 1 plus number 2. Again, why is that confusing? I don't think it is. You see, these data variables here are variables. And understanding, one of the things we're going to talk about next week is there's only 4 kinds of variables you can have in a Java program. So let's leave a slide in your PowerPoint as a reminder that this is something we want to talk about next week. Well, now I have an add method, but how do I use my method? I call it. I call my method. Well, now things are starting to get confusing. Because if this is static and this is not static, I cannot call an instance method from a static method. Don't get confused and don't get frightened, or I'll send Susan after you to beat you with a chair. Just follow along with me. The understanding will come once you've done enough examples of coding. You will call it in your void function. Yeah, exactly. That's correct. But there's one other thing we need to think about here. For right now, I'm going to make this public static add. And you'll understand later on why, because I want to call it from up here. So I want to say add 2 plus 2. So I want to call my add method from my main method. It is a fact about Java that you can only call static methods from other static methods, and that's why I'm doing that. And it's a bit premature to worry about why that is right now. I have another comment coming in. Yeah, exactly. We'll do some data conversions in a few minutes. We'll get there. That's a good point as well. But for right now, let's just make our little program run. Is this going to run? Well, if we were in Eclipse, we could use the debugger. We don't have a debugger here. Let's just try running it. So I'll say execute. Did it work or didn't it? What do you think? It didn't give an error message, so it didn't give an error message, but I'm also not seeing anything. Why am I not seeing anything? Because there's no output statements here. So here could be one way to do it, right? I could say, I could just output the result of this method call. So I could say system.out.println. That is how you print something in Java to the screen. It's just the code to do it. Why it's like that? Because that's the way the Java virtual machine is written to work. So we'll look at the details of the JVM in week 9 or something. But for right now, I think this will probably work. So do you see what's happening here? Oops, that should be a round curly bracket. I'm saying print line, and in the beginning we just printed out a message that said hello world. Now our print line is going to invoke the add method, and it should come back and it should output the result, which is 4, I think. The last time I checked, 2 and 2 was 4. Probably it still is. So execute. And now do you see what happens? So now we got, if you followed along with me, you now have a basic program. Now, starting from now, I'm going to put all of my code into our GitHub. So if you can't see the screen clearly or something, you can just copy from GitHub. So I'm going to copy this, and I'm going to go to my GitHub, Professor Brown Bear. So we'll say GitHub, and you can copy it into your own GitHub as well, right? I'll just call it starter 1, or basic file 1, basic example 1.java. And I'm going to talk about GitHub later on, but suffice it to say you need to commit your files. And you can go and get my code now out of there if you want to follow along with that. Make sure you can run this code because it's not getting easier after this. Just make sure you can copy and paste it to your online IDE and get it to run. Now, let's try amping this up a little bit. So now we've written a simple program, 1 class, 2 methods. Let's try writing another class. So I'm going to call this main class, and this is the pattern we do when we do programming. We have one class who's the organizer. It's like the shift supervisor, right? It's the guy who runs everything else. So we're going to say public class, and we'll just call it manager because it's managing everybody else's work. And I'm going to make another class here called calculator. So I'll say public. No, I can't call it public. So I can only have one public class in a Java application. So I'll just call it class calculator. And then classes are always, the implementation is given in curly brackets. And I can just click and drag this add method down here. And now I need to change things around a little bit because if I run this program right now, it's not going to work. Because now we need to do something called making objects from classes. We need to instantiate our calculator class and make an object. We're getting near the end of the class, so I'm just going to do pure code demonstrations right now. And I'm also recording this as a Camtasia video. You can watch again later. And you can also read in your textbook, right? So now I'm going to show you the code, then I'll put it in your PowerPoint slides. So here I need to do the following. I need to say calculator. So that's a reference to my type. And I have to give it an object reference. Call it whatever you want. I'll call it C1 equals new calculator. Calculator. And now I need to call the add method on my object reference to calculator. So I'll say c1.add, and I'll give it some numbers to add. And I can assign the return value of that method to a variable, so I'll call it result, and I'll output the result here. Is that going to work? Well, not quite. I'm still missing some stuff here. To begin with, this should now be a dynamic, not a static method call. Why? Because C1 is an instance. And if I don't put static, then it defaults to being an instance method call, and I have to call instance methods on instance references. I'll talk why about that is next week. Absorb. Just let it go into your brain. Let me brainwash you. Like, let me convince you that this is true, and I'll explain why it's true later on. Is it going to work now? Well, I have an object reference to calculator, and I'm calling a method on my object reference. I'm assigning the value to result, and I'm printing out result. I think this will work. I don't think I've missed anything. Let's give it a roll. Let's execute. Yeah. So 4 and 5 is in fact 9, so that's correct. That's good. So now do you see we've done something pretty sophisticated. We've written a main class, like our class which is running guys, which is the manager. He has the main method. And from in there, we're now instantiating other objects. Now let's say I want another method such as subtract. Let's try doing that. Oops. So I'll copy and paste this. And now I'll subtract. And I'll change the name of my method to subtract. And I'll call it up here. So I'll just say my instance reference, which is the object reference of the class. Here I'll say subtract. And let's see what we get here. So now let's run it. Oh. Cannot find the symbol. Oh, I think it's a spelling mistake. Yeah, I didn't spell subtract right. Okay, so I'll copy and paste. Okay, let's try it now. Yeah, so that's working. And now what else does a calculator do? It multiplies. So let's give and please see if you can follow along by yourself. Do your best to see if you can manage to follow along. And let's give it a multiply method. So we'll call it multiply. And here we can just, in computer terms, the star. If you press Shift 8 on your keyboard, you get the star symbol. That's multiply. And let's give it divide now that we're already about doing this. So we will say divide. And the / is the symbol of dividing in programming languages. Let's test. Here I'm going to say multiply. Yeah, 4 and 5 is 20, and now let's say divide. Divide. Divid. Oh, I have a comment coming in. No. Iveen, and I hope I'm pronouncing that correctly, no. Only Python cares about indentation. Nobody else cares about it. Why Python cares about it is because Guido, I forget his last name, there's an Italian guy, smart guy, a software engineer. He works for Dropbox, the company that makes Dropbox. And he wrote Python to be a language to teach his children. He had 2 daughters, like 3 and 5 or something, when they were very small. He wrote a programming language to teach children how to program. And he made it with indentation, so the program code would look like a storybook, so it would be easier for children to process. And everybody hates indentation in Python. We deeply wish if he didn't do that, but he did. We're stuck with it. So no, Java does not care. Java uses curly brackets, right? Python, well, Python does have some curly brackets, but in Java, it's your curly brackets you have to keep track of. Yeah, good question. Thank you. So let's keep going. Did I? Yeah, I guess I did all of that stuff. Did I? I don't know. I forgot. Where did I leave off? So 4 divided by 5 is not really 0, is it? Now we have to learn about different data types. Because if I say int is what? 0, 1, 2, 3, 4. I cannot have 5.5 as an int. So I can use float or double, right? So let's change our data types to float, because 4 divided by 5 is not 0, it's 0.8 or whatever it is. What did I? Yeah, that should be 0.8. So let's try saying float instead of int. And now we're seeing there are different data types. So paste. We have about another 10 minutes, so we'll keep going. Let's try it now. And now, if I'm typing it as a float, I have to be returning a float. You see here I said int, so let's change that to float. And my inputs I'll make to be floats as well. So I'll type my input, my method parameters. My inputs to my method are called method parameters. I'll type those as floats as well. Let's try. Yay, that's correct. All right, I'm going to give everybody my code because we're going to have one more activity before we're done today. So I'm going to update my Dropbox. So you can go to my Dropbox to get the most up to date. How do I update something? Excuse me, not my Dropbox, my GitHub. So I'm going to say edit this file. And I'll just copy the whole thing. And I'll say paste. And I'll commit my change. And if you go to my Dropbox, you will now get access to the latest code. So do that. Now, let's start by talking about loops, right? Because we also want to do some looping. Well, let's say that I want to make a multiplication table. Maybe I want to find out 0 times 0 up to 10 times 10. You know what a multiplication table is, right? Can we make a multiplication table? I think we can probably do that. Yep. So we already know, because we know about a principle that says you should break the behaviors of your classes as small as you can. So I'm going to make a method here, and I'll call it multiplication table. And I'll call it public for reasons that we're going to become clear eventually. Public multiplication. Actually, no. Where do I want to do this? Yeah, I can probably do it here as well as anywhere else. And so that's my method signature. Here's my method implementation. And here I'm going to go and say calculator, because I always have to create an object reference to my class so I can work with the object. So I'll say calculator equals new calculator. And now I want to call my multiplication table method. So I'll say c.multiplication table. And I'm going to do that by, the purpose of this is to introduce some looping, right? So let's say that I want to go from 0 times 0 up to 10 times 10. So I'll have some parameters in here, say 0 and 10. And then I'll accept the parameters in here, and I'll keep an int for right now, because usually a multiplication table is on natural numbers or whole numbers, right? If you made it by floats or something, it would probably get pretty big and messy. I have another 6 minutes. Let's see what I can do. So now I want to say int, int start and int end. And now how does for loops work? Well, I want to multiply and I want to output the result of the multiplication, but I'm going to say for, and this is the basic formulation of a for loop, right? In fact, let's make another class right now just to play with for loops before we put it here. So I'm going to make another class and I'll call it playground because it's just to play around with some code on. So class playground. And here I'll make a method. I'll call it public void for loops because I'm just going to play with some for loops. Just going to see how they work. And what have I said? And up here, I'm going to comment this out. So a comment can be done with a double slash if you want to leave something in your program but have it not work right now. And I'm going to say c.playground to run that method. I have 4 minutes. Let's see if I can at least teach you about for loops in 4 minutes. I'm going to say, oops, I have a comment. I have 2 comments coming in. Sir, why called multiplication table? Can you please, well, call it whatever you want. If you don't want to call it multiplication table, call it dog and cat. Just you have to come up with some name. The question is, why did I call it multiplication table? Okay, I'll call it dog and cat. Call it whatever you want. It's just so I can refer to it. Right, I'm putting some code in a method, and I'm going to call the method somewhere else. Come up with any name that's meaningful to you. Whatever name you want to use. Yeah. Now I'm writing a for loop. So practice using a for loop. Oh, I have another comments coming in here. Oh, I see. Why haven't you called the whole calculator class? Well, that's a good question, but since I only have 3 minutes left, I'm going to ask you to remember that question till next week. Or you can post it in Google Classroom and I'll answer it later. Because to answer that question, I need to talk about the structure of how object-oriented programming works. And it would be easier to talk about that after I've shown you one working example. So I will answer the question, but after I show you this example. Yeah. Just post your comment in Google Classroom and I'll answer it to everybody. But right now I want to see if I can do this in 2 minutes. So right now we just want to practice a for loop. So for loops work like this. They have a starting condition. So we'll say int I equals 0 if you want to start at 0. And then a semicolon. And then you have a guard condition. You keep saying do it as long as I is less than 10. And then you have your another execution context where you can increment stuff. You can say I++, which means I equals I plus 1. And now we can say system.out.println. I wish if this was a 4-hour class, by the way. A 3-hour class, by the time we really get things going, we're out of time. But a 4-hour class would have been better, but this is what we have, so it's okay, we'll manage. System.out.println. And we'll say value of I is, whatever is the value of I right here. Let's just run this one little for loop. is this going to run? Because I've defined a class and I've put my methods in the class, and I've defined an object reference to my class called C, and I'm calling my method to run the for loop in here. So that should run, I think. Let's give it a spin. Oh, invalid method declaration. Why? Oh, return type. I didn't give it a return type. Okay. Well, I'm not returning anything yet, so I'll just say void, and I'll say execute again. Required. Oh, what? No suitable method. What? Oh, I see. Yeah, I see what they're getting at. You have to use string formatters in this version of Java. All right, so we'll just output the value of I, but it is complaining about input parameters not being there. Oh, I see, because I declared here that I need two ints, but I didn't put them in my method call. So we'll call that 0 and 10. I know it's probably people are sending me messages that the class time is over, and I'm going to end the class in a minute. Let's just see if we can get this going. Yeah, so that is a simple for loop. Next week, we're going to pick up by using our class that we've written here, and I'm going to update this in... So what I would advise you guys, and I can tell I have some students here who are a bit on the advanced side. So my advanced students, see if you can finish up this code and you can get it to work to print out a multiplication table. And meanwhile, we'll all continue and do that next week. I'm going to dismiss the class in a minute. Let me just save this first. If you have any questions, let me know. I'm sorry we don't. If we had one more hour, it would be so good, but we're kind of ending a little bit early here, but that's just the way we have to deal with it. I copy. Yeah, maybe. That's possible I did. But anyway, guys, it's 2:01, and I know sometimes students have another class after this one or something you need to get to. Actually, let's do it this way. Class is dismissed, so if you need to go, go. That's okay. You can go. Class is over. But I'm going to spend another 3 or 4 minutes right now to finish this off. If you want to stay and watch me, you can. If you need to leave, you can. But I'm just going to finish this little bit up right now. So just let me do this thing here. So here is our IDE. And now we need to do, well, let's do the following. We need to have nested for statements, right? Because we have two numbers to multiply. So here I have for I equals, and then in here I'm going to have for j equals and now I can just multiply, right? So now I can just multiply. So I'm going to say system dot out dot println and I'll say I, j, and I times j because we're multiplying. Okay, I'll get to your comment in a minute here. Hang on. Somebody is asking a question, I think, which because they're drawing an arrow to something. I'll get to it in a minute, just a sec. So let's try running this. Say execute. Calculator, what? Class not found calculator? Error at line 4, calculator class not found? Why is the calculator not found? Oh, actual all right, hang on just a sec here. All right, calculator C equals new calculator, C dot dog and cat, and I'm passing in 2 int parameters, and I'm receiving 2 int parameters, so I don't know what they're complaining about. Well, one trick you can use for debugging is to just erase some of the code and then see if that makes the problem go away. So if I erase that and try running it, oh, I see. So the problem was in this code somewhere. So paste that back in, try run. Maybe it's like I put a curly bracket in the wrong place or something. Yes, so why is this happening now that I put this here? So I'm opening a curly bracket here, and I'm closing it here. I think I have a curly in the wrong place. So I'm opening here and closing here. And I'm opening here and closing here. And I'm opening here. Yeah, I have an extra curly. No, that's the method, and that's the curly for the class. All right, let's see what's going on. Yes. Well, I did say leave, right? If you want to leave, then leave. Go, class dismissed. I'm going to keep doing this. If you want to stay and watch me, it's fine, but I'm starving too, by the way. I'm just going to finish this for anybody who wants to stay here and keep seeing it. You're welcome to leave. Class is over now, so I did say you can just go if you don't want to be here anymore. That's right, go. But I just want to figure this, because this should be working now. Why is it saying there's no class? You see, when I erased this stuff, then the problem went away. So the problem is in here somewhere. If I get rid of that, and I say execute, there is no problem. And I know there's a comment. I'm not going to look at the comment right now. Go. Class is over. Just leave. Go and have lunch. It's fine. I just need to figure this out. It's bothering me. Why does the problem happen when I put this here? So I'll say execute calculator at line 4. Why does having that code there make a problem? Yes, we are. We're going to do it next class. Lovepreet, leave. I'm going to actually kick you out of the class. I'm going to say throw them out. I'm tired of hearing about you and your lunch. You and Susan go and have lunch together. See what she does to you. I need to figure this out. The one thing I'm thinking is I put a bracket in the wrong place, but the brackets are correct. No class definition found at line 4? All right, this bracket is for here and here. Okay, I'm just balancing my bracket. By the way, if you're using Eclipse or something, it automatically warns you if your brackets are incorrectly balanced. So doing this by hand, one good thing is it forces you to think about this by yourself. So here, all my opening and closing brackets are balanced. Here is for my for loop. Here is for my method. And here's for my class. See, now there's no error. But now there's an error. So the error is in this code somewhere. For loop, it's less than 10 and above the value is 10. Yeah, maybe that is that the problem? Yeah, here it's going, I is going from 0 to 9. So that's 10, right? And here it's going from 0 to 9. No, those are okay. Okay, what happens if I take this? I'm trying to figure out why this little bit of code is making there to be a problem. It's saying it can't find the calculator class. See, now it's working. Now there's no error. So I'm going to build this up one little bit at a time. Because what I want to do is multiply 0 times 0, 0 times 1, 0 times 2, and then 1 times 0, 1 times 1, all the way up. You see, that's why I'm having nested for loops. So I'm going to say for I equals 0, I is less than 10, I plus plus. That's a simple for loop. I see comment. I see the comment. I'm just ignoring it because class is over. It's going to bother me. I can't enjoy eating my lunch till I fix this. So if you guys want to hang around with me, great. I'll see your comment in a minute. I need to try something first. I is less than 10. That's a for loop. So this for loop should work. There should be nothing wrong with this code now. So we'll say execute. And it's an error. Interesting. Yeah, Kieran, you might be right. That could be correct. But I don't think that's the cause of this. This is a bigger problem, right? It's saying it can't even find the calculator class. That's the big thing it's complaining about here. Cannot find symbol. Oh, I can't find symbol I. Oh, because I forgot to say int. I think that's what Kieran was saying. I forgot to type my variable. All right, maybe that, because since I erased this and I'm retyping it, maybe this is the thing now. Yes, now it's running. Now it's okay. Let's see. Now I have another chat comment. Do we need to describe? Yes, that's right. You need to type your variables. That's correct. You need to give types to your variables. So now I think what happened before was I misplaced a bracket. So now every time this runs, I want to do the following thing. I want to have a nested for loop with j, or with some other variable. So I'll put this here, and I'll say j is the controller variable. And now let's see, but now it should work. So now we say execute. Oh, one error. Illegal start of a statement on line 28. Oh, I see, because I forgot. You see, I forgot to put curly brackets to provide an implementation for my for loop. So execute. Okay, now I have no errors. All right, good. Now I can do the following. Now I can print out the result. You know what a multiplication table is, right? You know what I'm trying to do? Images. I mean, I know you know the concept. Maybe you just call it by another name or something where you went to high school. Multiplication table. I want to make something that looks like this. See, I want to multiply 1 by 1, 5 by 6, all the way up till 10 by 10. That's what we're trying to get to here. So now I'm going to say system.out.println, and I'll just say I times j. Let's try that. Yes, that's working, so that's good. All right. Now here, I want to accept as parametric inputs yes, exactly. Yeah, so Mandeep got it. That's correct, and that's correct. Good. So now I'm hard. See here, I'm hard coding 0 and 10, but I should be accepting the values from here. I should be using start and end. So 0, wherever there's 0, there's going to be start. And wherever there's 10, there's going to be end. And here, start. And here, end. And that should work the same as it did before. So let's say execute. Yeah. All right, now we need to do something else. Well, I think this is enough of an accomplishment for right now. Now, next week, and in fact, I'm going to put some comments here, I'll say to do. This is like a little way of annotating your comments so you remind yourself where to pick up next week. I'm going to say use if statements to break it up and to make it a nice table, right? To make it so it has columns and rows. Use if statements to break the output to make a nicely formatted table. And if you guys want to do that by yourself, great. That's a good exercise. I will update this in my GitHub, and then we're done for today. Thank you guys for hanging around with me. Shows you're interested in this. That's great. Formatted table. So I'm just going to kick this up to GitHub, and then I'm going to end up the class, and I will post the Zoom video later on when we're done, when it's done processing. So say copy, and where did I put GitHub? Where's my Git? I lost it. here. So I say click on the pencil to edit. All right, guys, now class is over. Now the next little bit is going to bring in if statements, and we'll talk about those later on. So thank you very much for hanging around with me, and I hope we have a lot of fun. You're welcome to bring your own problems, right? If you have been wrestling with some other programming situation and you can't get it to work or something, let me know and we'll make it into a case study. All right, guys, I need to go and eat. And my dog, I have to walk my dog. I have to do a bunch of stuff. So I'm going to say goodbye now. Please email me if you have some questions. And please study your nice textbook that I gave you. And spend a few minutes between now and next week. Jump into the online IDE. Maybe try messing around. Just take the code from the textbook, copy and paste it, and watch it work. Thanks a lot. See you guys later. Bye-bye.